Welcome to the technical closing session of the United Nations Costa Rica PSIPW 6th Conference on the Use of Space Technology for Water Management. In this technical closing session, we will hear closing remarks by Professor Pascal Giraud from the University of Costa Rica, followed by conclusions, recommendations, and gaps that the moderators of each session have identified. The closing remarks are delivered by Professor Pascal Giraud. As I mentioned, he's currently holding the chairmanship of the School of Geography at the University of Costa Rica, where he has taught since 1987. He has worked from 2014 to 2018 as a senior advisor on climate change at the Ministry of Environment and Energy of Costa Rica, and is a member of Costa Rica's climate change negotiation team. Teaching for 30 years as a full professor at the School of Geography of the University of Costa Rica, Pascal has worked since 1990 as an international consultant for the UN Development Programme, the UN Environment Programme, the IADB, the Food and Agriculture Organization, and IUCN. I'm not sure what all of the acronyms mean. I'm sorry for that. He's held international positions at UNDP, IUCN, and CARE. In particular, his work in Latin America and the Caribbean has focused on environmental and climate policy, land use planning, and protected areas, with special emphasis in disaster risk reduction and adaptation to climate change. I'd like to add here that I've heard numerous times this week what an inspiration Professor Giraud has been to professionals in the field. And with that said, I would like to give the floor to Professor Pascal Giraud.
Thank you, Nina. Good afternoon, everybody. It's an honor and a pleasure to be here with you and to share a few thoughts on the issue of space technology and water management here from this region. I'd like to thank also UNOSA, the ICA, and the Ministry of Foreign Affairs of Costa Rica for kindly extending their invitation for me to join this conference. Unfortunately, I was traveling early on this week and I couldn't join you at the start of the conference. But I've been trying to follow it from afar, and I've been talking to several participants during the day and yesterday, and obviously this has been a very exciting meeting. I think there's been a lot of very good presentations on what's being done across the world on the use of space technologies, remote sensing for the use of water. I would like to reflect on two issues that I think are key to this. One is, obviously, as a geographer, as a person who's been on the the user end of geospatial technology, obviously, the importance of looking at end use and demand and final use of geospatial data is critical. We tend to think that the supply side of spatial technology or of imagery is enough. And I, over the years, have seen over and over again how we tend to think, as in my case as a geographer, that if you have a good map and a good satellite image, well, why don't they use it? Why aren't people picking up on this more effectively? Why is it so difficult for this information to be translated into action, translated into effective water governance, into managing emergencies around the availability of fresh water resources for human consumption or for agriculture? And I think it's important to try and delve deeper into this reflection. I think that this week's conference has been a fantastic opportunity to share experiences across different countries, across different continents, different regions, in terms of how does this really work out in practice? and what are some of the pointers and the lessons learned in terms of making sure that not only do we have state-of-the-art information readily available for water managers to manage more adequately their resources, but how can we also make sure that the information is in a format and is made available in a way that people can really manage effectively the resource. I think the current climate emergency also puts us in front of a conundrum. Emergencies are not good for planning. Emergencies tend to make us haste and to skip certain key steps. One of the things that I have observed over the past few years is that the speed of change in technology, the amount of data that is currently coming online in terms of spatial resolution, in terms of radar imagery, is surpassing the capacities of many countries to process, to store, to analyze. So I think that one of the biggest bottlenecks is how can we work more effectively in alliance between government agencies, academic institutions, NGOs, and other key players that can really help get the job done, get this information not only available, but also processed, analyzed, digested, and acted upon. How can we also help with this information attend not just the emergencies, but the long-term planning? A lot of investments that are needed to enable access to water resources for irrigation or for domestic use require also careful planning, long-term investment, and long-term commitments. And we need institutions for that. And those institutions in many of our countries are being dismantled as we speak. So we have to be wary also that economic crisis is not a good, it's not good news for water resource planning or use of these kinds of technologies. There's a lot of dispersal also and duplication of efforts. I've seen it here in our country, but I'm sure it's the case in many other countries around the world. Data governance and education at all levels is critical in my mind. And finally, I think we also need to look more carefully at the issue of inertia. How can we also go beyond the business as usual that tends to govern a lot of our institutions, and also plan for more constructive work in terms of how can we improve the governance of information, of climate data, of Earth observation? How can we train more professionals? And that's my remit as the chair of a school that has been training geographers now for close to 50 years. And I think the challenge here is how to keep up the pace of the change in technologies and the very rapid changes that we are observing because of climate change. So I think we have two challenges here. How can we can accelerate the capacities to change our ways of doing things? How can we accelerate our technical capacities and training and access to education? And how can we also improve data management and data storage, and hopefully under a open data lens, to make sure that all this information is hopefully freely available for those who most need it, because we still face a lot of barriers to access the information, to make critical information available to local rural aqueducts who are managing scarce resources and who don't have the capacity to buy a lot of this data or to process it. So I think to finish, hopefully this conference can help us build alliances, build partnerships. Hopefully we can start working across the board, both with government agencies, academic institutions, research institutions, NGOs, and local governments in unison. And hopefully this conference will give us key pointers. And I look forward to hearing some of the conclusions that Nino and others will share in this closing event on how we can do this in the shortest possible time. And again, thank you all for your attention. And thank you once again for inviting me for these closing remarks.
Thank you very much, Professor. You finished a little bit before, so we have time for one question, one burning question to Professor Giraud.
I'm seeing signs in the back with red cards.
Yeah, it's good, good. Is there one question? Maybe from the online presenters. If not, we will have time to discuss later on. After Ameria, do you have a question? It's just a microphone. Okay. In this case, we will continue with the conclusions, recommendations, and gaps for session 3, theme 3, on satellite communication, a facilitator for IoT-supported water applications. We start with that order because we have an air emergency, I think, and this is presented by Shanglong Lu, who's a hydrological and wetland remote sensing scientist with a focus on advancing technologies for water resources management, environmental monitoring, and ecological conservation. Lu has developed several methodologies. Among his achievements is the creation of an unmanned water detection system platform tailored to comprehensive monitoring of water resources, water environments, and water ecosystems. Additionally, he has pioneered in remote sensing techniques for monitoring dynamic changes in water surfaces, as well as devising methods for estimating lake water storage and river runoff using remote sensing technology. Lu, the floor is yours. Thank you.
Thank you very much for your detailed introduction about me. I'm sorry to disturbing this report order because we need to leave early to catch our flight. So we skip too quickly to our session. As we are here, our session's title is Satellite Communication Facilitator for IoT-supported water applications. Here, before I make our summary, I want to restate this new concept or definitions about satellite communication or satellite Internet of Things. It refers to the use of satellite technologies to facilitate communication and data exchange among IoT devices located in remote and or inaccessible areas. In this figure, there's the logic how this system are working together. And during our session, here have some key informations about our sessions. Here I noted some numbers. The first, we have 3 speakers, 2 on-site and 1 online. Then from 3 countries or continents, 1 from Egypt, this is from Asia, and Peru from South America, and 1 from France for Europe. So this is a very international session. And then we have 3 water-related topics mentioned. The first one is agricultural water resources management, and the second one is water quality, and the last one is cacao farming, also related to soil moistures and vegetation conditions. And also we received 5 questions from our floors. And then goes to the key informations from these 3 presentations. The first one, IoT device integrated with satellites, opens up a new possibility for real-time monitoring and data connection in remote and inaccessible areas. The second one is the integration of advanced sensors and satellite communication systems enables us to track water levels, consumption patterns, agricultural dynamics with unprecedented accuracy and efficiency. And the third one is IoT sensors can send data concerning water quality and issue a local alert regarding Campylobacteria. This is just case studies informations. And the first one is the constellation of satellites will accurate data for the entire area concerns and enable the possible identification of the potential sources of contamination and the projection all over the impact. The final one This is for cacao farming. In the future, required observation of cacao plantings a full growing time period and has to including the irrigation, fertilization, pest management, plant diseases, and ecological side effects. That means we need using this kind of IoT and satellite communication technologies to monitoring or managing this kind of parameters. Okay, the final slide here have some knowledge we get and future trends we concluded. The first one, with these new technologies, in fact, we have very good application progresses. Here I mentioned some. The first one, we can globally connected and then assert tracking and monitoring, and we can do environment monitoring, emergency response, precision agriculture, etc. And another one, we also meet some challenges during the recent situation. The first, it is costly to using these technologies, and then the latency. And the third one is the limited bandwidth, and the fourth one is power consumption. I think yesterday, one of our colleagues from Egypt have mentioned this, how to make this power consumption more continually. And the final one is the interference and the signal blockage. And then for future development outlook, here have some, this is for us, is good for us to using this technology. The first one, the expansion of satellite constellations in recent years have greatly improved. And then advancement in satellite technology. And the third one, the integration with 5G networks and the emergence of edge computing. And focus on sustainability, the diverse applications and regulatory considerations. All this information just from or above our sessions. Okay, this is my sharing, and thank you very much for your sharing. And finally, personally, I would like to invite all of you to visiting China, to sharing your knowledge and your experience with us. In fact, in this September 6 to 8, we have a big event. The first international forum on big data for SDGs will launched in Beijing. We warmly welcome you all to join us. Okay, thank you.
Thank you very much. I would now like to invite our next speaker. We will have 4 in a row focusing on theme 1. But the first one to speak is Jorge Gutierrez from the Food and Agriculture Organization. Jorge is coordinator of the Vapor Project for Colombia. He holds a PhD, or he's a PhD candidate in geography and has been conducting research on climate change for the agricultural sector for more than 15 years in Latin America and the Caribbean. He currently coordinates climate change issues for FAO Colombia. And Jorge will summarize the session on water scarcity, space technologies to monitor precipitation, soil moisture, and drought. Jorge, the floor is yours.
Thank you, Nina. Thank you, colleagues. First of all, thank you for the organizers of this very interesting conference, no? Maybe we share the idea that all the information and the ideas around water and space was successful. Okay, in our session, we can to share with 2 colleagues in presence and 2 online from Algeria, Gambia, Ghana, and Bolivia. Some ideas of our conclusions. First of all, there is a growing interest in measuring monitoring precipitation, soil moisture, and drought in intermediate and local scale projects. Was very interesting, this kind of understanding in each scale. There is a favorable increase in current methodologies of source of information for measuring and monitoring precipitation, soil moisture and drought. One of the main interests of local governments is in finding faster, more cost-effective. Now, we share in another session this issue, the cost of the information. For studying droughts through risk monitoring platforms, there is a word that is emerging in some cases in another discussions, risk. Climate variability phenomena such as El Niño are increasing, motivating their influence and analysis around drought process. Current analyses are identifying the possibility of optimizing agricultural productivity with drought-resistant seeds. Maybe there is issue that don't touch a lot of in these sessions, but is emerging too. And because our region, they are frequently affected by this phenomenon, no? The research presented in our session showed that they are in common point regarding the urgency for implementing sustainable water management strategies to address the escalating water scarcity challenges. And finally, was interesting talk about how Google Earth Engine and some processes and data provides effective monitoring for soil moisture in some series of time through ISMAP global soil moisture. Like final recommendation, it's for us important to continue increasing collaborative work and creating networks, not only South-South and North-South, in data management and sharing successful experience in the evaluation of the variables that we take in our session. Thank you so much, colleagues.
Thank you, Jorge. I would now like to invite the next speaker, who is Driss El Hadani, Senior Advisor at the UN Office for Outer Space Affairs since 2023. He provides expert advice, support research for the activities and programs implemented by the office in the fields of space science and education, and manages the office's activities related to UN-affiliated regional centers for space science and technology education. He has more than 30 years of experience in the field of remote sensing and space technologies, applications and development, and holds various degrees. I'll keep it short here. Driss, the floor is yours. Please introduce the conclusions, recommendations, and gaps for the session on informed decision-making for agricultural interventions and irrigation decisions.
Thank you, Nina. And here we are at the end of this really interesting conference. And we are trying to share with you the most important conclusions of our discussion during this this technical session on the informed decision-making for agricultural interventions and irrigation decisions. During this session, experts from international organization, national, regional organizations shared their insights and their views on various perspectives that how satellite data could contribute to monitor water management when it comes to agriculture and to tackle subjects like water efficiency, water productivity, and irrigation optimization. During this session, we had 4 presentations. The first one is the VAPOR project initiated by FAO, was presented by Jorge Guterres from FAO Colombia. The second presentation is also about the VAPOR, but the use of this platform at the national level. It was presented by Kartikeyan from the Consortium of International Agricultural Research Centers. This is the application, as I said, of this VAPOR to a very local use in Mozambique. The third presentation was about the project called Koala that was developed by the University of Vienna and supported by a Copernicus program. The last presentation was also a national study called IRISAT Maroc on the use of satellite data for an operational irrigation management based on remote sensing data. The goal of this projects could be summarized in 3 points. First one is how the satellite data, the satellite technology could support achieving food security while ensuring sustainable use of water resources and facing very critical challenges as it was detailed during the first presentation in the first day. The second goal of this project is effective monitoring of water use in irrigation to increase productivity. We know that agriculture is one of the biggest consumer of water resources, and there is a big challenge how we can optimize the use of these resources, how we can increase productivity and reduce or decrease the amount of water used for this agriculture. The third objective is more a support for decision making, how this projects or this technology could provide governmental authorities and local actors with accurate, timely, precise information so they can make operational decision and implement operational projects. The benefits and the services that was shared by experts during these presentations could be summarized as follow for each project. For the VAPOR project, FAO, it's a public and accessible real-time satellite database, which is a big, I think, opportunity for different countries that could benefit from this project. Monitoring the agricultural water productivity is provided by this project at different scales. A global scale at 300 meter and 100 meter scale at continental level, and also in some places in different countries. And I remember well, it was that more than 13 countries are now covered with satellite data and with the products from VAPOR with a resolution with 20 meter resolution, which is a very high resolution. One of the services and the benefits from this project is how we can monitor crop health in the field with a precision, etc. And the overall objective is how this technology could support building resilience in food security systems by providing data and information. The Mozambique, which is a more local utilization, a more precise one, is how VAPOR helped these countries to identify specific irrigation schemes and intra-schemes variations with low land utilization and productivity gaps, which is an important factor that could support decision makers and authorities to optimize the use of water. The project also was useful to highlight water use hotspots that require targets and interventions, and it provides system and subsystem at the levels of all these spots to support stakeholders. The Kuala project enhances irrigation efficiency, reducing water use, and improving fertilization practices. We know that fertilization is important for agriculture, but also it's a very cost activity and also with a lot of side impacts of damages for water resources. This kind of benefits is very important if we can develop the use of satellite data to optimize and to improve fertilization. It will also have another impact on the quality of water resources. It supports although sustainable crop management and at the global scale. It's a regional project, and even for the Moroccan project IRISAT, it improved the use of water in agriculture, and it generates indicators at different levels, serving farmers, local authorities in charge of water resource management, but also the national level with the ministries of agriculture and water resources. Most important to discuss in this discussion, what are the challenges that this kind of projects are facing? The first one is related to the data quality, data accuracy, and data resolution. I think this is one of the most important topics that was raised during the discussion, because the variability of data resolution, temporality of data acquisition, and other parameters are also limiting the efficiency of this kind of project. The second one is the ground truth and validation. The question was raised in discussion that this is a very good models, very good tools that were developed, but they are suffering from difficulties to obtain accurate ground truth data for the validation of the models and also to improve the quality of the results of these models. This third challenge is the integration with local systems. You know that there are a lot of experience, a lot of knowledge is acquired with the local systems, and one of the challenges how to connect this solutions based on satellite data with local systems. Capacity building and training. It's important that the end user at the end of the process should be able to acquire the system, to master the system, and to be able to run and to use the system on an independent level. So capacity building is also one of the challenges. Data accessibility and sharing was raised many times in discussion during this session, but also in other sessions. And one of the topics that was also discussed during this session is the infrastructure for data processing. You know, this satellite data are a very huge amount of data, a very large volume of information, and it is require adequate infrastructures and adequate tools to be used and to be implemented. The takeaways from this technical session for the platform Vapor, it's a very significant tool that provides accurate data. And I think also the fact that it's open, it's give opportunity to a large number of countries to benefit from this. Collaborative efforts are very important to develop operational solutions. This project was developed in with an international organization, and the contribution from different countries, from different organizations was a very important key factor in the success of this project. Comprehensive data analysis at schemes and intra-schemes level. So this is a project that could provide information at global level, local level, and also very, very precise level. Koala platform is a powerful tool for precise data-driven irrigation scheduling, and the integration of data also enable to reduce costs when it comes to protection of agricultural resources. And it was important to stress that innovation is a key element in this approach. This Koala projects demonstrate that offering this innovation to the community enable to benefit to farmers, to policymakers, and also one of the elements that was shared during this presentation. Now this startup is also trying to build a new business model, so to bring this project to a very large community. Last one is the Moroccan project on Erisat, which I think demonstrated that operational irrigation management require high resolution data, which is important to stress at this level. The combination of different models improve the quality of the outputs, and also that this kind of project contribute to the implementation and the achievement of specific roles defined by a government in the field of agricultural development in the country. This is the outcomes of this technical session, and thank you very much for your assistance. Thank you.
Thank you, Driss, for your thorough assessment of the inputs in that session. And we'll move to the next moderator, Ameria Baitu. Ameria is a professional and with an academic background in space technology and its applications for environmental monitoring and management, with a master's degree in geographic information systems from the Africa University of Dar es Salaam in Tanzania. And Ameria Baitu is gonna tell us about her conclusions, gap assessment, and recommendations on the session T1S3, space technologies and their relevance for groundwater monitoring. Ameria, thank you for your contributions, and the floor is yours.
Thank you, Nina. Good afternoon. We had a session whereby we had 5 presenters, 3 online and 2 were on site. The title of the presentation, as it can be seen there, the space technology and their relevance for groundwater monitoring. The first presenter was Hafsa Aman from International Water Management Institute, CGIR, Pakistan, and University of Wuhan, China. She tried to show us the methodology by using PCAA. And the second person was Badia Cheli, a Water Research and Technology Center from Tunisia, and also Elizabeth Guzman Hidalgo from the Faculty of Engineering at the National Resource Management, from the National Autonomous University of Mexico. And the fourth one was Amos Kaboba from the University of Energy and Natural Resources, Ghana. And also the last one was Ana Rodriguez. All of these presentations showed us the benefits, the relevance, the gaps, conclusion, and recommendation. The relevance of this presentation, all of them tried to show us the space technology, the advantages, concern about the remote sensing, whereby provide data for different analysis, especially in soil moisture, land use changes, vegetation cover. And also the geographic information system, how it integrates with the other data sets. And also the relevance tried to show us on use of GPS, especially in tracking or locating the coordinates. Basically, you can do it maybe for ground potential zone. The benefit of these presentations, all of them tried to show us how the space technology covers. It covers a larger area compared to a traditional one. And also it is a cost effective because most of the data are free, despite the other data, you can do it in the physical or in situ data. And the benefit, that was the third one, it was timely data acquisition. For example, the SAR data, the revisit time is about every 6 days. Also, these presentations had conclusions. All of them tried to conclude that space technologies are revolutionizing groundwater monitoring, providing valuable data for informed water management decisions. The second one was integrating space-based data with the ground observations leads to more holistic understanding on groundwater resources. But literally, they tried to see the gaps on the data, especially when using space technology. They showed that on data access and quality, for example, in the LiDAR data and radar data also. The technical expertise is a bit challenge because most of us don't have much time to take on using this kind of space technologies data. And the last one was data integration. It seems the integration in diverse data sources required robust infrastructure like the spatial database, maybe the national one, or having the big data to store the imageries, compare that imageries require enough space because of that storage. And the recommendation of these presentations was on international collaborations. They needed everybody to share the idea, the knowledge, the material in order to improve the groundwater management sustainably. The second one was a capacity building program, as our fellow presenters have said, in order to improve, especially for managers or stakeholders, which uses water to be capacitated to have a better knowledge of space technology. The last one was standardized data protocols. Most of the areas doesn't have standardized data protocols. So as everybody suggested, to establish common data format for ease integration and analysis, for example, the ISO standards. Thank you very much. Good evening.
Thank you, Ameria Baitu, for your conclusions and recommendations. And the next moderator that I would like to invite to the podium is Ms. Mandira Shrestha from the International Center for Integrated Mountain Development, ICIMOD, as well as Harriet Odhiambo Okal joining us online, who works at the Stockholm Environment Institute in Kenya. Mandira Singh Shrestha is a senior water resources specialist at ICIMOD with over 25 years of research experience covering broad areas, climate services, disaster risk reduction, and water resources management, with her main areas of expertise including transboundary flood forecasting and monitoring, applications of satellite-based products, regional cooperation, hydrological and hydraulic modeling for hydropower projects, early warning systems, and end-user engagement for reduced risks and increased resilience. Harriet, who's online, Harriet Okal, is a research fellow and associate researcher for water systems at the Stockholm Environment Institute Africa Center. She's in her final year of a PhD in hydrology at the Institute of Water Research, Rhodes University in South Africa, with her research focusing on integrating remotely sensed data to reduce hydrological modeling uncertainty for sustainable water resources management in sub-Saharan Africa. And I give the floor to you, Mandira, to present to us on space technologies, monitoring flood risk and impact, and relevant climate change adaptations in agriculture.
Thank you very much, Nina. Very good afternoon to you all. It's indeed a pleasure to be here. And now we are on the fourth day of this very exciting and interesting conference. I'd like to thank the organizers, particularly Nina, for this opportunity, not only to be here, but also to be moderating such an exciting kind of a session, talking about space technologies, monitoring flood risk and impact, and relevant climate change adaptation in agriculture. So in this particular session, we had, of course, my colleague here, Harriet, and myself moderating this session. And we had 3 people speaking online, and 3 of them were here in person. Those that were speaking online, we had Rodney Martinez from the World Meteorological Organization. He was speaking on space technology for flood management, giving various examples of tools and applications that are available through the World Meteorological Organization activities. The second online presentation was on leveraging multi-satellite remote sensing data and machine learning for flood risk assessment in the Namguan River Basin in Lao PDR. And making this presentation was Sakdawong Mangishan. He is with the Kyushu University right now as a student and is also working in Lao PDR. The third presentation that's online is the satellite-based framework for comprehensive assessment of crop loss in flood-affected regions in Sindh flood during the Sindh flood 2022 in Pakistan. Making this presentation was Sawid Abbas. He's with the University of Punjab in Pakistan. Then we had 3 in-person presentations. The 3 in-person presentations, the first one was made by Ana Miriam Valvarados Vlasius, and she made a presentation on identifying annually flood-prone areas to aid communities in developing improved agricultural practices from El Salvador. Then the second presentation online, in person was flood modeling for the Cagayan de Ono watersheds. Making this presentation was Faye Oceanos, and she is with the Department of Bureau with the Philippines, with the environment. The third online presentation we have is analysis of drought flood, abrupt alteration events, and the agricultural impacts in Kenya. And we had this presentation by no other than Betty McKenna from the University of Nebraska, Lincoln, and she's a graduate student at the university. So these were who are they? Please have a look at whether you recognize all of us here. So making this presentation online, you can see the 3 of them, and then in-person online presentations by the 3, and you can also see the Harriet. So the conclusions. I mean, it was an interesting session, basically, with quite a rich 6 presentations that we had talking about flood risks. So definitely the conclusions was floods is the most severe hazard affecting millions globally. And so it is the most deadliest in the world. So there's no doubt about that. The second conclusion was that it's not only floods, though. We need to be also looking at compounding kind of hazards. So there are compounding events that are becoming major challenges. And these compounding events, what are those? Well, they are floods. There are also droughts, like we heard during the sessions, and also landslides and glacier melting. And the third conclusion that we came up with, and examples that were provided during the presentation, was that there are many applications and tools that are available for flood risk reduction. And the examples that were provided by WMO was the flash flood guidance system. The other opportunity that we see is that AI and machine learning is very important, particularly looking at early warning systems and looking at impact-based forecasting and warning. The fifth conclusion or a message that we have is definitely Earth observation fills in the existing data gaps. We talked about the data from the ground, the in situ measurements, and that is not adequate, particularly in high elevations, as well as in other rural areas. And Earth observations provides that opportunity to fill in those data gaps and provide the information that is much needed for flood modeling, as inundation mapping, and use of various other kind of satellite products like the GPM, as well as Sentinel products and data. Yes, outscaling and upscaling of methodology is very important, and that does provide us an opportunity. And with examples of crop damage estimation during floods in Pakistan was provided. Then GIS, geospatial information technology, can be used for risk assessments, for vulnerability assessment, sensitivity analysis, and basically these could really inform decision-making in terms of the buffering, for instance, an example that was provided by the Philippines. Early warning systems is a prerequisite. And so for this, definitely, we have Earth observations, data information, providing that information much needed to provide the early warning to the communities for better preparedness. Then the ninth conclusion that we came up with is space technology provides support for estimating impacts, and particularly looking at loss and damages. So this is an excellent way to look at it for crop areas, but also not only limited to crop areas, but overall in terms of disaster risk reduction. And the very important point, which we've already heard from other presenters, is the fact that there is a need for long-lasting capacity building, capability building, training and education in space-based technology. So these were the conclusions. Quickly on the gaps. There were a lot of gaps, definitely, but three we would like to highlight. The first is on the use. Yes, there are plenty of data, plenty of information now being available. Yeah. But we are challenged by what? Challenged by its application. Who's going to be using so much of data and information? How do we make sure that this is being used? Yeah, so that is one of the gaps that we have. The second gap we have is in terms of the capability and the capacity of the various users, in terms of access, in terms of interpretation, as well as use of the various data sets and tools. These are very limited. So there's an opportunity in terms of filling this gap. The third is, yes, there are many good practices, as we heard during the conference, but how do we ensure that it is uptake? So what's the uptake? How do we do that? So that's one of the gaps. Yeah? Now, let's look at the recommendations. We came up with quite a number of recommendations from the presentations. Yeah, the first one is, yes, it is a tool, and then we should look into using it for loss and damage assessments, loss and damage estimation. I'm not going to read every one of it in detail, but then also the second recommendation was to look into applying the AI tools, particularly for risk management in the agriculture sector. Examples from Chato in El Salvador. Then development of flood susceptibility mapping for disaster risk reduction. That also provides an opportunity. Then development of early warning systems. I think this has been elaborated quite a bit, and there is plenty of opportunity in which we use the Earth observations to address all the 4 elements of the early warning systems: risk knowledge, and then we have monitoring, and then we have the communication, and the 4th one is in terms of response capabilities. Yeah, so there is this opportunity. Then access to satellite data, how to make it accessible, we talked about platforms. There are a number of different platforms. So how do we make it such that this information is easily accessible to the various users? Yeah, so that is something that we would like to recommend. Geospatial information technologies, and deploying that, using that for the vulnerability assessments, risk assessments, for particularly making decisions. Then long-term capacity building. For long-term capacity building, we call it the institutional capacity building. So it's not only of our individual capacity, but the institutional capacity to ensure that there is access, interpretation, and use of satellite data and information. Then we have raising awareness, co-development, because that's the important word, co-development and of these products, co-design of these products is important, particularly for the ownership. And this is very important to link to the users at the local level. There's also a lot we're talking about in terms of community of practice, COP. Yeah, so this community of practice, this provides an opportunity for learning and sharing. So this is something that needs to be also followed through. And finally, the last recommendation that we have come up with is the cooperation and collaboration. So this is between and amongst institutions, as well as countries and globally, to promote our partnership for better use of satellite-based data and information to save lives and property and infrastructure. Thank you very much.
Thank you very much, Mandira, and also Harriet Okal joining us online for your profound conclusions and recommendations. I think I will definitely look them up and get into more detail with that to improve also what we do at UNOSA. The next conclusions and recommendations and gaps being presented by Mr. Amjad Ali from the Pakistan Space and Upper Atmospheric Research Commission, SUPARCO. And I forgot to copy your biography into my sheet, but give me a second. Just a second, I have it. Yes, it is. Well, sorry. Please give a short introduction of yourself. I apologize for this. And the conclusions by Amjad Ali from SUPARCO are given on the session on space technologies for monitoring glaciers. Mr. Ali, the floor is yours.
Thank you, Nina. I don't know if you already shared my presentation. This is not the one. It is more about the glacier monitoring, maybe with a different format. Just to save time, shall I? There's a problem with the presentation, I think. I hope you have already shared. Anyhow, just to refresh on the knowledge that was shared in that particular session. That session was related to the glacier monitoring using space technologies. There were in total 4 presentations planned, but out of that, we have only managed to have 3. And 2 were on-site and 1 was online. And the on-site presenters were Mandira Singh Sharishta and Eileen Sol Orton. Okay, there were some gaps which I have identified in that. The studies were presented more about the, the state. So, there is more, yeah. This machine is not helping me. Okay, I think I have already presented this. So we are here. I think this is these are the gaps that we need hypertemporal remote sensing to make it possible to to monitor glacier, because the glaciers are highly dynamic phenomena. Quantitative assessment of climate change is required, because nowadays most of the work is related to the qualitative assessment, but it should have been more in terms of the quantitative assessment. Regional simulation for probabilistic and predictive mapping, that is also now important to have it, keeping in view the availability of more machine learning and AI algorithms. Similarly, the structural properties of snowpacking is also very important to understand, keeping in view the climate change scenarios, because how the snow structure is actually formed, whether it is a wet or it's a dry snow. So I think this is also important, and it's also high technology, oriented topics. And this is also a very good topic even for PhD to follow. There should be improvement in the in situ data available, because, in the high altitude, especially, glacier areas, the in situ data is a big problem, because everywhere you receive a big rain, snowfall, and then every, the in situ equipment that you have already installed, most of them are damaged, or it is, damaged by or flown away by the avalanches. The structural aspect of glaciers is again very important, as more and more data is available in 3D context. Similarly, studying the causes and effects, glacier depletion, slow melt, and runoff modeling with more detailed and high resolution data, coupled with atmospheric condition. I think these are the gaps which we need to fill in days to come. In conclusion, I would say that it is a highly effective tool, because these glaciers are always in a very highly inaccessible areas, and it's a very difficult terrain even to go there and even to collect the data. There are a lot of hazards even associated to collect the data over there. So I think space technology is the only way to do that. Let me say it very strongly. Multitemporal or hypertemporal data is helpful in estimation of current state, future prediction of the cryosphere. It is vital to have a spatial-temporal information. Climate change impact is critical in case of glacier. So I think the emergency arrangement should have been in place for effective protection. Similarly, the hazards associated with glaciers, of course, very important, because a lot of people are affected by the glacial hazards and avalanches. Quantitative assessment and modeling of the mass balance is important to the system in detail. I think the recommendations are common with all the other technical sessions, so I will just list it down. Effective institutional arrangements are important to be in place. I think one should ensure continuity of future observations. Adopting and reporting climate indicators are important in case of glacier. I think the accuracy of the climate observation is also a big issue in case of the glacier research. We should arrange more and more in situ data, and there should have been a special arrangement for sharing of data experiences of different regions. Thank you very much.
Sorry. So not only did I jump one of the moderators, but I also didn't copy Amjad's introduction. Now I would like to give the floor to Mr. Stephen Greb from the University of Wisconsin-Madison, who speaks to us about space technologies for water quality monitoring and sustainable agriculture. Stephen Greb is a researcher for the Space Science and Engineering Department of the University of Wisconsin-Madison, as mentioned, and has recently stepped down as the director of the Group on Earth Observations Water Quality Initiative called GeoAqua Watch.
Perfect. Thank you, Nina. So it's an exciting time in our field here. Some amazing things are going on in this. The use of satellite technology for water quality is evolving very quickly, changing all the time. As a matter of fact, it can be a full-time job just trying to keep up on who's doing what. So I think a lot of the discussion from the other moderator chairs could be applicable here, as you'll see. Observations, things that came out of our actually we had two sessions. One that, just to put it in context, there's literally billions of dollars being spent on satellite technology, the R&D that goes into them, the building of these satellites, launching, all the infrastructure that goes with it. Yet there's only a small portion that's being spent on the application or tech transfer, which is somewhat of a shame. As I mentioned, the science and technology of satellite remote sensing of water quality is continually evolving. And our capacity to measure and quickly disseminate water quality information, it's changing quickly. And I would say we'll have a whole different discussion a decade from now. There'll be some amazing changes that are occurring right now. There's many factors we've heard about that contribute to the degradation of water quality. We saw parallel situations, different areas of the globe which have similar problems, be it ag runoff or untreated sewage or climate change, of course. A common thread of the talks that we had in our session was, how do we increase the confidence of the information that we're producing and the services that we're generating? So the uncertainties are just as important as the actual value. We continue to stretch our capabilities to use these tools, from exploring different ways or ability to distinguish algal types, functional groups of algae. We had one talk, kind of a conceptual plan for pesticide applications in the agricultural context. On a different note, we heard about work going on at the watershed level, not just measuring direct water quality, but what are the watershed and climatic factors that influence current and future water quantity and quality conditions. So we heard about a lot of different water types: lakes, streams, rivers. The mega delta region was quite important from looking at contaminant plume transport. With the tour that we took the other morning, which highlighted the SAAs, we saw how management agencies are developing risk management tools defined by hazard exposures, vulnerability, and capacity, and successfully using this info to manage their basin. And so using some of the GIS tools, geographic information, compiling a number of different layers, they are putting together this comprehensive risk assessment to inform for the assessment and to inform investment in future issues. We heard a lot about harmful algal blooms. Again, it's a common theme or common issue globally. We're hearing about it more and more. In advancing the use of satellite remote sensing to better quantify HABs and bloom ecology is ongoing. Gaps and barriers. I think it was, again, this was mentioned in some of the previous talks, but we need to have a better understanding of what the end user needs are in terms of what their parameters are, and also the timing, the temporal and the spatial resolutions that they need this information at. We also need to make them aware, increase the awareness of remote sensing information with the end user community, that there are these new sources of data. I think there's a lot in the community that don't know or don't have any, are unaware of the types of data that are available. We talked again about errors. Of course, we're focused on errors in the remote sensing information, but also we need to point out that there are errors in existing methodologies, be it when you go out and collect a sample, how representative that is of that water body at that particular point in time, or that particular place on the lake. Remote sensing does offer some further information, again, on spatial variability of some of these water bodies. We've seen there's some institutional and regulatory barriers where water quality limits are codified or in the law, and so there's a certain way that's specified to collect the samples. So again, to help to further the ingestion of this kind of information, we need to look at some of the institutional and government regulations. We talked somewhat about the in situ data needs and the gaps in data needs, and how there's this unequal distribution of in situ water quality data globally. Optical equipment is really expensive. You know, how can we get it to the people that need to take these in situ measurements for CalVal work around the globe? You know, when we have these new satellites being launched, as the PACE mission was launched here in February, which is a hyperspectral mission, of course, we're going to need more sophisticated in situ measurements, hyperspectral measurements for, you know, for the CalVal work. And of course, training opportunities, which is one of the reasons, of course, we're here this week. We need more opportunities for capacity development. Our recommendations, CalVal, greater coordination and sharing of optical data and water quality data by data producers. We can't do this alone. We need to work on issues like this as a community. We each can't go off in our own direction or work in our own silos. Hopefully work towards the building of a global validation network. And again, meetings like this are good to, you know, to discuss things like this and to, again, start developing these relationships between institutions. We need increased training and capacity development for building this expertise. And we need to find success stories. Just as Jim Nelson talked about, a few of the success stories in the water quantity area, success begets success. We need to get the word out, you know, our capabilities, and you know, have some good stories to share. And we also had some discussion about citizen science and how do we cultivate a citizen science network to engage the local community. And this can come back full circle to what the end user needs. So, you know, co-development, I heard, you know, co-development of you know, building what products we need for the future. So I think that's it. So I appreciate it, and thank all the presenters, and thanks for the opportunity to share with you today.
Thank you very much. And who hasn't had enough? Tomorrow there will be a training, but we have enough participants for this training. So I'm lucky if you registered already. I will now briefly summarize what Professor Jim Nelson and Edgar Espinoza have shared with me in terms of the conclusions, recommendations, and gaps that they had for the session under theme 4, Space Technologies, Monitoring Forests, Agroforestry, Watersheds, and their interplay. And to conclude, they recommended to say that there were different applications using space technologies to develop models demonstrated during the session, defining parameters and land use conditions. Digital elevations are critical for watershed monitoring and modeling. Satellite technologies are also useful for monitoring change over time, as we saw with the mangrove example and the disappearing RLC. But they must be combined with robust in situ monitoring data to improve bias and calibrate models derived from global Earth observing systems. There's also considerable discussion relative to the capacity development and training of stakeholders to use and trust in these information systems for decision-making and policy formation. And I need a pointer. The gaps that they identified was to find better ways for capacity development and the need for continued support of in situ information to improve space technology solutions. And here we see that's the same for the water quantity and water quality data. We need in situ data and we need collaboration. And in this country, there is great potential for this with the faculty-based approach of the ASADAs, I think. Recommendations are that as scientists and users of this information, we need to clearly communicate value and to be honest with its limitations so that we can effectively advocate for the resources necessary to close the gaps. And that's it from session theme 4. And finally, I would like to also give a very short comment from my side, or summary from my side. I think we saw. Can you open the slides, please? So I think we saw numerous inspiring presentations, lightning talks, panel discussions. We had an insightful field trip, beginnings of cooperations and collaborations. We gathered wonderful people. And with this event, I would say it was quality over quantity. I think we had a wonderful experience here, and I look forward to the trainings tomorrow. I would like to mention that we still have spots for the streamflow modeling training by Professor Jim Nelson. And I think this is a very unique opportunity. So I invite anyone who has not yet registered and who's interested to approach us so we can fill up the spots. Yeah, I think we've got the best conclusions by the moderators. I took notes myself, but for the sake of time, since we have only 15 minutes left, I would like to keep some time to also give the floor to the audience to share whatever has not been expressed so far. But I would also like to ask you for a favor. And that is to scan this QR code and give us feedback on the conference so we can improve your experience at these kinds of events. You don't have to do that right now, but I would like to ask you to do it as soon as you get out of this room, maybe after the session, because you're all busy and you have important work to be done, but we also need to learn from your experience. So I would like to thank you for doing that. On the trainings tomorrow, just some logistical notes. From 9 to 1 o'clock, you will be trained with 1 coffee break and a lunch afterwards. The shuttle, for those who are funded participants going back to the hotel, leaves after the lunch. So if you need to get to the airport earlier, you need to arrange your own means of transportation. And I already mentioned this. So now I would like to raise a question that was asked via the form that we had. That was one question on glaciers. Just a second, please. Need to get there. I took too many notes now. The question was submitted by Sonali Zol, and the question is, if there is monitoring technologies for glaciers, then in India, Ladakh and Himalayan glaciers are affected due to infrastructure and business project in terms of development, then how in this scenario we could protect glaciers, even if it's not only affecting India, but also neighboring countries and overall atmospheric changes in wind systems, oceanic currents due to temperature and pressure. How could we be balancing infrastructure and nature? Are there any strong suggestions that if we found glaciers are melting in certain regions through monitoring, would UNOSA strongly have its interface or set guidelines for countries, because guidelines seem to be not followed, which is recently affecting climate and temperature? We humans in the present situation today are facing extreme heat waves. Does anyone whose work focuses on glaciers? Yeah, I'm also thinking of Mandira for the regional vicinity. If you have some answer to this question, please share it. If not, I invite all the other speakers on glaciers to share some comments on this. Here's the microphone.
Well, a very good afternoon again. And Sonali, thank you for your question. Particularly, I understand from your question that you relate to the transboundary aspects of glacier monitoring. As rightly said, Ladakh, Himalayas, as well as many parts in Nepal, as well as in Bhutan, they are transboundary in nature. And as I was mentioning in my presentation, often in these areas, when in one country, there is the origination of the glaciers and the glacial lake outburst floods, while the damages are often incurred in the downstream. So there is an urgent need for cooperation and collaboration between and amongst the countries, particularly in terms of sharing data and information, knowledge, as well as setting up mechanisms for putting in early warning systems. It is vital importance that the countries upstream inform the people living in the downstream in the countries so that there is less damage that is incurred during such disasters. But apart from that, yes, there could be a lot of science exchange between the countries, not only in the Hindu Kush Himalayan region. I think that much that is going to be learned also from other regions, as was pointed out in the presentation, from the Andes. So the South-South cooperation in terms of sharing of knowledge and experience would be also vital in terms of enhancing this. So I would like to stop at that. Thank you.
Thank you very much, Mandira. Now we have time for another round of questions. We have 15 minutes before the closing of the event starts. No, we have 10 minutes. I'm sorry. 10 minutes before we formally close the event. Do you have any questions? Anything you're curious about? Any comments, suggestions? I guess you're tired. Yes. Freddie, sorry, please introduce yourself briefly so the online participants also get a chance. And
thank you. First, thanks to everybody who made possible our participation here. For us, it has been a great experience to meet you, to know all your work. And just I'm curious about how do you follow up this kind of experience? Because I wouldn't like to lose the contact with everyone. Of course, we've been talking one-to-one, but that was it, Nina.
Thank you for the question. I think I can answer that. We will assess all the input provided in the feedback form. We will digest all the input of the conference and write a report that you can all read. But then we will also stay in touch with all of you. You're all invited to join the Space for Water community if you haven't done so. And there we have regular meetings, way more regular than the conference series. We meet twice a year. We're also starting the webinar series where you're all invited to share your contributions. I also had the idea of maybe using the video recordings we have of this and having this as like an input during the webinar series. And then for those who are interested in that, a Q&A session with you one-on-one for the rest of the hour. I think that could be benefiting several more people than made it here to this conference. But you all have the brochures and the flyers, and there you have the QR codes to the forms, how you can become a member of the Space for Water community. And we all have your contacts. I hope you exchange them too. You're all invited to join us at stakeholder meetings. As I said, the next one is in October. It will be hosted in a virtual mode, but we also meet at the stakeholder meetings in person once per year. This year was an exception because we had the conference. Is there any other question? Maybe from the online participants?
It's just a comment. It says, thank you for the opportunity to be part of the conference.
Thank you very much, Anonymous. Thank you. I really would like to thank all of you for your contributions. And at this point, I take the opportunity of having another 6 minutes. I would like to thank the admins who brought you here. I would like to thank the IT. Can you come out of your chamber, please? Who've been working in the back of this room. I would like to thank the live interpretation and the interpreters we had during the entirety of the event, the students of geography and all other subjects who supported us, being rapporteurs, being chat moderators and operating the slides and screens. Please come. And of course, I would like to thank our host country, Costa Rica, for their hospitality, and especially the hosting institution, ICA, for inviting us to their beautiful campus and co-organizing this with us. Please all come to the stage. You did a wonderful job. Jonathan, come. We need to swap roles here. Give me your phone. And you can come too. We can take a group photo. Thank you so much. Oh, this is good. The light, yeah. Yeah, turn it off. It can go and get some rest too. Thank you very much. And now we are ready to formally close the event. And as I heard, there will be a moderator from, no? Okay. There will be no moderator apart from me in this closing of the event. And that means I will introduce our next speaker to deliver her closing remarks. Just a moment. Ambassador Carmen Claramunt Garro, the director of the Diplomatic Academy, Manuel Maria de Peralta, and a member of the Advisory Council and Scientific Diplomacy of the Inter-American Institute for Global Change Research. Ambassador Claramunt studied law in the University of Costa Rica. She has 2 postgraduate degrees in international law and a PhD in international economic law, with emphasis in economic investments. In addition, Ambassador Claramunt holds several diplomas and academic master's degree in French literature. Prior to her current position, Ambassador Claramunt was alternate representative to the United Nations in Geneva, Director of Foreign Service and Deputy Director of International Cooperation. And I now invite Ms. Claramunt to come to the stage and deliver her closing remarks. Thank you so much for being here with us. It's an honor. And thanks for the beautiful conversations we had earlier.
Yeah. Can you hear me? Thank you very much indeed. Good afternoon to all of you. It is my pleasure to share these closing remarks on behalf of the Ministry of Foreign Affairs and Worship and the government of Costa Rica after a very, very fruitful and comprehensive 4 days of works that I understand included even a field trip yesterday that allowed the participants to get their own hands information from the asadas, working directly with the communities. For Costa Rica, it has been a true honor to host this conference. My country's commitment towards the environment and its relation to social and economic development come from decades ago. Nonetheless, we are aware of the multiple and stressing challenges we have upon us. As Ms. Allegra Bayoki, resident coordinator of the United Nations in Costa Rica, mentioned on her opening remarks, this week we were surprised by the news of having an electricity crisis due mainly to generation difficulties in hydroelectric plants as a result of the low precipitation and droughts affecting our country. Electricity rationing had not been done in Costa Rica for almost 20 years. We also have risks associated with water scarcity and water shortage, as well as the problematic framework of water use during extreme droughts and floods. Hence, it is important for Costa Rica to implement its drought and flood management strategies at the regional level, provide incentive structures to improve the match between crop and water stress, and improve its governance in water resource management with respect to financing, urban planning, education inclusion, and ecological preservation. Long-term solutions for water management will address emerging risks and vulnerabilities to climate hazards, as well as move towards halting irreversible losses in terrestrial, freshwater, coastal, and marine ecosystems by connecting, integrating, and fully implementing water-related decisions made in global assemblies, conventions, and frameworks dedicated to climate resilience and the environment. We must use global water information systems for better water management, climate resilience, early warning, and risk-informed decision-making, and implement environmental economic accounting to unlock investments for building water-related climate and environmental resilience. And this is why your presence in this conference was fundamental. All of you have shared with other participants present in this room and online creative and innovative ways to address the challenges that our countries, most of us in the global majority, face in order to provide a sustainable and equitable management of this vital liquid to our communities. I want to thank you and the speakers who presented online, many of which had to stay up late at night due to the time difference, because you have made an enormous contributions in shaping the current and future steps that countries affected by climate change and associated risks are dealing on daily basis. We heard about a study that focuses on meteorological drought in the Gambia, a country visited by a river and heavily reliant on agriculture that experiences a long dry season which significantly affects crop yields. I'm sorry. Also, Mr. Akshir, who shared with us about the geospatial mapping and analysis of surface water demand, consumption, withdrawal, and availability in the Tano River basin of Ghana. In this panel about informed decision-making for agricultural interventions and irrigation decisions, Mr. Jorge Rodriguez from Food and Agricultural Organization in Colombia explained us about the WAPER project that employs remote sensing to enhance water productivity, measuring biomass and evapotranspiration effectively. And given the open access nature of the database allows for versatile use of the data across different platforms. In the same order of ideas, Ms. Hafsa Anman from the International Water Management Institute of Pakistan spoke about assessing vulnerability and co-designing climate resilience water management strategies for rural communities using geospatial data sets, a study that uses key research components such as GIS-based risk mapping and review of existing policies and gaps, and identifying gender barriers, decisions and empowerment, mapping of and proposing policies and action plans. Meaning it is a study that combines climate change challenges with geoinformatic solutions. I could continue naming all of these wonderful presentations, but these are just a few examples of high-level technical information that was shared among the sessions. There are many more, as well as the important latest remarks and recommendations that I invite everyone to review further in the ICA YouTube channel. I believe that this conference was a fantastic opportunity to achieve one of the main objectives of the Space for Water project, which is to build a community that includes fostering a global network of stakeholders to share knowledge and resources. From the Ministry of Foreign Affairs, we are committed to be part of this global ecosystem of collaboration and knowledge sharing necessary to address complex water management challenges effectively. We invite you to keep track of the high-level event on Ocean Action, Immerse in Change, to be held next June in our country, in preparation to the third United Nations Ocean Conference in Nice next year, which Costa Rica is co-hosting. It will bring an opportunity to inspire both individual and collective action for ocean conservation, while also serving as a platform for exchanging best practices and sharing successful experiences. To conclude, I would like to express our gratitude to the United Nations Office for Outer Space Affairs, Mr. Dries El Hadamni and Nina Kickinger, for their outstanding efforts in organizing this event. And a very special thanks for our friends from the Inter-American Institute for Cooperation on Agriculture, ICA. Given all your enthusiasm and your collaboration, Mr. Jonathan Castro and Ms. Diego Monge, along with all the people that have been part of the protocol team, the sound team, the interpretation, the catering, the interns. Congratulations to everyone who did a fantastic work. And to all participants, including the two professors that will give the high-level trainings tomorrow, thank you once again for sharing all your knowledge and tools to keep on working together in achieving the sustainable development goals that are meant to end hunger, poverty, and provide clean water and sanitation to all in a more gender equal and sustainable world. This conference is a very excellent example to strengthen and stimulate the linkage between science, diplomacy, and public policies to benefit for the benefit of human beings. Thanks indeed.
Finally, I would like to invite Driss El Hadani, Deputy Director or Senior Advisor of UNOSA, to deliver his closing remarks.
Thank you, Nina. It's my pleasure and honor for me to stand before you today at the close of the United Nations Costa Rica Prince Sultan Ibn Abdulaziz International Prize for Water, 6th Conference on the Use of Space Technology for Water Resource Management. Over the past few days, we have delved into the transformative potential of space technologies to tackle the urgent challenge of sustainable water management. Throughout this conference, we have explored the diverse ways in which space technologies are making an impact on water management across the globe. The sessions addressing water scarcity and agricultural interventions underscored the importance of satellite data in optimizing irrigation practices and improving water productivity in agriculture. Projects showcased from various parts of the world demonstrated how remote sensing and data analytics are revolutionizing irrigation management by providing near real-time insights into water use efficiency. Groundwater monitoring took center stage as we explored change adaptation. We learned about the immense potential of combining machine learning with satellite imagery to create comprehensive flood susceptibility, I said groundwater monitoring took center stage as we explored innovative solutions for estimating groundwater recharge and managing transboundary aquifers using Earth observation data. Cloud computing and advanced remote sensing tools were highlighted for their role in providing timely and accurate information crucial for effective ground management. In the sessions concerning flood risk management and climate change adaptation, we learned about the immense potential of combining machine learning with satellite imagery to create comprehensive flood susceptibility maps. These approaches are helping decision makers anticipate and manage floods, risks, and vulnerable rivers basins, reducing the impact on communities and agriculture. Water quality monitoring remains a cornerstone of effective water management, and this conference highlighted groundbreaking research in this area. From the Asian mega delta to Latin America, we saw how satellite imagery is being used to assess water quality dynamics, detect contaminants, and monitor harmful global blooms. Global initiatives like Geo Aquatwatch are empowering water professionals to utilize satellite data for better management and of surface waters. Ladies and gentlemen, these discussions and presentations have reinforced several key conclusions. First, international cooperation and collaboration and knowledge exchange are paramount. We must continue sharing technologies and best practices, ensuring that every nation benefits from the collective expertise and data that we possess. Second, capacity building initiatives must be expanded and replicated globally. The hands-on training sessions that we organize at the conclusion of our conferences, including the one on water quality scheduled for tomorrow, were designed to equip participants with practical skills to implement space-based water management solutions in their countries. Third, enhancing data accessibility and integration is crucial. Open data policies and platforms like the VAPOR and GeoLaws and other should be scaled up to support decision makers with accurate and timely information. Lastly, partnerships across sectors must be strengthened. Governments, private sector, academia, and civil society need to work together to develop innovative financial models and policy frameworks that drive sustainable water management. Ladies and gentlemen, as we conclude this conference, I would like to thank the government of Costa Rica for their generous hospitality and the ICA team for their unwavering support. I am deeply grateful to our co-sponsor, the Prince Sultan bin Abdulaziz International Prize for Water, and all our partners for making this conference a reality. My heartfelt gratitude goes to the organizing team from UNUSA and the Ministry of Foreign Affairs and Worship of Costa Rica, as well as ICA, for their meticulous efforts and dedications. Your tireless and collaborative spirit have ensured the success of this conference. Congratulations for job well done. To all the participants and experts, I extend my heartfelt thanks and wish you safe travel and continued success in your future endeavors. Let's continue this journey together, harnessing the power of space technology to ensure that sustainable water management becomes a reality for all. With our dedication, I have no doubt that we will continue to make meaningful strides toward achieving our goals. Muchas gracias and thank you.
Goodbye, online speakers. Thanks for your attendance.